In this video, I will be explaining how to use RStudio to estimate a logistic model and also to make some prediction. The problem says 30% mortgage applications are obtained to analyze the mortgage approval rate. The response variable y equal 1 if the mortgage loan is approved, 0 otherwise. It is believed that approval depends on the percentage of the down payment, S1, and the percentage of the income to loan ratio, X2. So we have here an example of a problem that can be solved using the logistic model. First, the response variable is a dummy variable, is a qualitative variable that have 1 if the mortgage loan is approved and 0 otherwise. And then we have some predictors, x1, in this case we have two predictors, s1 and x2, two explanatory variables, or we can say two independent variables. So we have one dependent variable that have two values, 1 or 0, yes or not, and we have two or more, in a logistic model, explanatory variables or independent variables. The data in the problems are given in an Excel spreadsheet. I have here a part of the Excel spreadsheet, and what we want to know, or what we want to do, is to estimate and interpret this logistic model. So we have a qualitative response variable, and we have in this case two independent variables. So after that estimation, what we want to do is to predict the loan approval probability for an applicant with a 20% down payment and 30% income to loan ratio. So this is an applicant that is giving a 20% down payment for the mortgage, and also the income of this person is 30% of the loan. So the income to loan ratio is 30%. We want also to estimate what happens if the down payment was only 4%, or if the down payment is 30%, or if the down payment is 60%. So we have here several situations, and we want to estimate what is the probability that this new applicant will be approved. So what to do? So of course, the person is to open RStudio, and I'm going to explain how to use this RStudio to estimate this logistic regression. So the first thing that we need to do is just look for the files in your computer. So the computer need to have this Excel spreadsheet. So let's go here to files in this part of the window, in this pane. So you can click here on files and look for the files in your computer. So you click here on files, you're gonna see all the folders in your computers. I will be looking for here in documents, then I look in the same way that you look for any files in your computers. I have these files, mortgage, that is the file that have the data that I'm going to use. So I click on the files, and there are two options. They open two options. One option is view file. If you click here, you're gonna see the file on the Excel spreadsheet in your computer. But what we want to do is import the data set. So I want to import this, so I'm gonna click here in import, and appears this. So this is the file in your computer, and if you have this Excel workbook with several spreadsheets, you can choose here, click here, and look from which Excel spreadsheet you want to download the file. Because this workbook have only one sheet, I'm just going to press here import. But if you have several worksheets in this workbook, you need to choose here the sheet that contains the data that you are going to use. Because I only have one worksheet, I'm just going to click here import. So when I do that, in the window, in this first pane of the RStudio, will appear the data set. So actually we can see here the three variables, y, x1 and x2, and appears the command that represents in R what you have done, because you have clicked here folder, you have import, and this is the command that you were actually using in R. Okay, so now that you have this, you need to run the logistic model. To run a logistic model, then what I'm going to do is write in here the command I need to run the logistic model. I'm going to explain this command here beside the RStudio window. So I'm going to write this in this way: logistic mortgage equal GLM open bracket, and there are some arguments in these functions. I'm going to use the function GLM, and I'm going to explain everything that I have been written here. The first thing, you see, I put a name to the model. I call it logistic mortgage. So you can use here whatever name. You need to give a name to the model. It could be mortgage, it could be logistic M, or it could be M, just M, or whatever name, but you need to put a name for the model. You're going to use this function, but inside the function GLM, you are going to write first what is the model, what is the response variable, what is the dependent variable, and what are the explanatory variable or independent variable. And you need to use the name of the variable that appears here at the top of the Excel spreadsheet. This tilde that you need to use separate the response variable, the dependent variable, from the independent variable. You also need to type this third argument that I write in here, data. This data is going to tell you from where you are getting the data. You are getting this data from this Excel spreadsheet mortgage. So you type here the name of the file, data. You need to write data. This is the argument, data equal, and then the name of the file that you are using. So this GLM, as I told you, is the function in R to fit in the logistic model. Actually, GLM is for general linear model. So there are several linear models that can be run with this GLM. So you need to tell R what is the linear model, what is the distribution that use your general linear model. And this is a logistic model, use a binomial distribution. So the family, that the second argument that I have here, is the family, or what is the distribution that your data use. For the logistic model, must be binomial. So binomial is the family for the logistic model. So if you type this thing that I have here, a name of the model that you give equal GLM, etc., you are going to make RStudio to run the logistic model of this. Obviously, you want to see the answer, you want to see what are the coefficients of the model. So for doing that, you should write here summary is the command. So you're going to type it here, summary, open bracket, and type the same name of the model, the same name that you give here to the model. If you call it mortgage, you need to type here mortgage. If you call it logistic M, type here logistic M. Summary is the function for printing the output of the model. Okay, so that's what I'm going to do here. I'm going to write logistic model equal this, and then enter, and then summary logistic mortgage. So I type it here, and when I press enter, after I press this summary function, RStudio gives me the output of the model. So you can see here the coefficients and the p-values. That it will be the important part for estimate the model. We have that this is the logistic model. Remember, in this case, we have only two predictors, two independent variables. B0, B1, B2 are the coefficients you want to estimate, and these coefficients are here. So you can see here the coefficients, and you can see here the p-values. So you're going to see if the if this coefficients is relevant or not, if this variable is relevant or not. Also, you can see the significance of the coefficients, and depending on what level of significance you are using, but usually people use 0.05. If the p-value is lower than 0.05, means that these coefficients will be relevant. And you can see here that all these are relevant. Yes? All the p-values are smaller than 0.05. So these are the p-values, and this first one is the coefficient for B0, the intercept. So this logit will be equal to minus 9.367 plus B1, and B1 is the 0.31. So B1 will be, appears here beside X1, yeah? 0.35, and this is B2. 0.7822. You have estimated the model, and you have also noticed that the coefficients are significant. So these variables help me to explain the model because the p-values are smaller than 0.05, at least with 5% level of significance. Okay, now that you have estimated the model, you can make some predictions. So let's see how to make the predictions in RStudio. Remember what was the problem? The problem said predict the loan approval probability for an applicant with a 20% down payment and a 30% income to loan. But actually, what we want to predict is what is the probability of being approved if we have 30% income to loan ratio and the applicant is putting at the beginning as a down payment or 20% or 4% or 30% or 60%. There are actually 4 questions. So what I'm going to do is write this predict logistic mortgage. So the name of the model, remember, that's the reason you give the name to the model. For this predict function, we have 2 arguments. The model that you are going to predict and also a data frame from which data you want to make the prediction. And you want to make the prediction when x1, the down payment will be 20% or 30% or 4% or 60%. Here these numbers in x1 represent percent, 28.74 are percent actually. And these x2 are also percent, but these are going to be percent, what is the percent of the income respect to the loan. Remember, you will need to type the name of the model. The second argument is a function, treating in this way data dot frame open bracket x1. So this data frame is the function to create the list of values. So for example, if you want to create only 20% down payment and 30% income, so you just type x1 equal 20, x2 equal 30. But if you want to make several predictions at the same time, you can combine the values. So you are going to use the same name of the predictor, x1 and x2 here. Predict is the function in R for predicting the model, and also notice that I'm using this C to combine several values. So this C is using for writing a matrix, remember, in RStudio or in R. So in this case, I'm going to use combine to have a vector of values for the value x1, 20, 34, and 60%. And x2 will be the 30%. So x2 equals 30. So when I press this here, beside the prompt, I'm gonna get the predictions of each of the data. For example, I notice that the logic, it will be minus 1.3223. And these predictions are the prediction of the logic. So remember what was the function logic? The natural logarithm of the estimated probability divided by the estimated probability of not approval. Yeah? So the natural logarithm of the odds will be equal to this. So this natural logarithm is minus 1.3224 in case that the down payment is 20% and the income loan ratio is 30%. So this will be negative 1.32. This will be 0.026 in case of both numbers are 30, and etc. So usually this is not so useful because what we want to do is what is the probability. If you have this, you need to type, for example, equal minus 1.3224 and then solve for pi to want to know the probability. So obviously R can do this immediately if you type this predict function in another way. So far here you are predicting as it is well a linear model. So these numbers here are just the predictions of the logic of the model. But how to predict the probabilities actually? So let's do that. So we want to predict the approval probability. So I'm going to write the function in this way. Predict. So I'm going to use the function predict, logistic mortgage, data frames. I'm going to type the data frame argument, but then I'm going to add a new argument, type equal in quotation right response. If you do that, then the prediction will be the prediction of the response. and the response is actually the probabilities. So I'm going to write here predict and press enter. So as you can see, now the answers are probabilities 0.2104, 0.5066. So the probability of being approved, if you put a 20% down payment and a 30% income loan, it will be 0.21. The second one is with the 30% down payment is 0.50. With a 4% down payment, the probability of being approved is just 0.02. And the probability of being approved with 60% down payment and 30% income loan ratio, it will be 0.98, almost 100%. So in this case, this is then the estimation of the probability, PI, if you write it in this way. And obviously, the answers are always going to be positive and less than 1. And what you have predicted is this, the predictions of the logistic model. PI equal E to the exponent is the logit divided by 1 plus the exponent here is the logit. So this, you have estimated what you want, the probability approval. And with this, I finished to explain this. I hope you have found it useful. Thank you.